Hello, for those of you that don't know, my name is Dawn Houston. I'm the editor of Spud Smart magazine. We know it's a super busy time of year, so we want to thank you for hopping on this webinar, which is the first in a new partnership with NAPSO. We are tremendous fans of the work that NAPSO is doing, and we're super proud to be partnering with them. I'm going to be handing things over to Emily because this is totally her show. But before that, just a few housekeeping details because I know this format is a little different than you're used to. The webinar is being recorded and we will have it available on the NAPSO and Spud Smart websites probably around Monday. And we're going to be monitoring the chat. So there'll be a Q&A at the end. Please put any questions you have in the chat. And if there's anybody having technical problems, just put that in the chat too, and I can navigate as best I can. So thank you again. And Emily, I am turning this over into your capable hands.
Thank you, Dawn. Like Dawn said, NAPSO is joined in a partnership with Spud Smart. So from now on, we'll be hosting webinars together and doing some publications together. So NAPSO as a whole is really excited about this partnership. We really think this will move us forward into a more professional group. So we're really excited about that Spud Smart partnership. I've just got to go through the antitrust statement and then we can get into our speakers. So the antitrust laws apply to individuals just as they apply to any individual group or group of competitors. Competitors may not restrain competition among themselves with reference to price, quality, or the marketing of the goods or services. And they may not agree or act together to restrict the competitive capabilities or opportunities of other competitors, their suppliers, or their customers. Therefore, it is agreed and understood that there will be no discussions whatsoever at any meetings, whether part of a structured formal meeting session or informally at breaks among members or otherwise, involving areas in which any of the parties compete, including pricing, product pricing policies or terms, product marketing strategies, customer territories or locations, or other competitive aspects of a company's operation. Meeting participants have an obligation to terminate any discussion, seek counsel, or if necessary, terminate the meeting if discussions might be construed to raise any antitrust issues. Okay, so our first presenter is, we'll go through both of them. We have two presenters today, Todd Forbush from Techmark and Erica Zwaneveld from McCain Foods. Erica will be going first as the first speaker. So Erica Zwaneveld is the lead safety coordinator at McCain Foods. She was raised on a farm in New Brunswick. Erica developed a deep-rooted passion for agricultural safety and employee well-being. Her academic journey spanning multiple degrees has fueled her dedication to advancing health and safety across various sectors. As a certified chartered professional in human resources, a Canadian registered safety technician, and a Canadian registered safety professional, she brings a wealth of expertise to her field. Throughout her career, Erica has been committed to serving diverse communities, working in remote areas as well as both in the public and private sectors. Her expertise includes managing a store in a small remote northern community, providing HR support at the territorial government level, and offering HR and health and safety guidance at the municipal government level. These diverse roles have allowed her to apply her knowledge, effectively enhancing the well-being of employees and organizations she supports. In her current role as lead safety coordinator at McCain Foods, Erica continues to leverage her extensive background to drive and initiate that promote agricultural safety. So Erica, you are live.
Perfect. Thank you. I can hear everything. Is everybody hearing me okay? Just drop into the chat. So just a little bit about me. I missed the intro. I didn't have any audio. But essentially, you're probably wondering why I'm presenting around field and storage safety. I actually grew up on a potato farm, and I actually spent most of my childhood into my early teens and adulthood working in my family's storages. So I have a little bit of experience, and then over the past 3 years, I've been supporting our corporate farms here at McCain around agricultural safety. So just some little facts. So we all had close calls, or unfortunately an incident that ended with an injury. The Canadian Agricultural Safety Study has, which was published in 2020, shows that most producers have at least had one incident, either a close call or injury at their operation at some point in their lifetime. And that number actually goes up to almost a quarter have had one in the past year, with younger producers more likely to have an incident within the past year as well. Around safety of work, about 78% of those who were surveyed felt that they did work safely most of the time, but 2 in 10 felt that work was done safely all the time, which kind of aligns with what the injury rate is. It's 78% think they're doing it safely most of the time, 24% of close calls and injury in a year. So that makes sense. Identified risk, especially around crop producers, mechanical was one of the highest risks that was identified. With the amount of equipment that we use in storages in our fields, it's mostly mechanicalized compared to other producers in the industry. And then younger or millennial producers have actually identified or tend to identify more risks in their operations than older producers, which goes back to the thinking of, we recognize risks when we start doing things, but as we do it for a long time, we kind of become blind to the risks. And it goes down also the implementation of safe practices. Old habits are hard to break. So, if you're trying to break a new practice in, barriers around old habits can be problematic, and also the amount of time it takes to introduce safe practices on agriculture. And the reason I want to talk about the facts was just it kind of sets the guidelines as to what my presentation is going to be talking about and why I focus on certain areas. So just the basics. We can't talk about safety without talking about basics. Worker rights and employers' responsibilities go hand in hand. A worker has the right to know the hazards, so the employer or the producer needs to inform them about the hazards in the workplace and provide appropriate training, information, and instruction. Workers are working on or with these pieces of equipment, so empowering them to bring up concerns and make suggestions to protect them and their coworkers go a long way, and that's their right to participate in health and safety discussions. And of course, if they are asked to do something that is unsafe or they haven't been trained to do so, they do have the right to refuse work, especially if they believe that work poses an imminent threat to their health and safety. You can mitigate this by providing a safe and healthy workplace where hazards are properly mitigated, and also ensuring that PPE is being used, that is appropriate PPE, and it's used properly. As an employer, you do want to make sure that you have your workers know what to do if there is an incident, and that you have someone trained in first aid along with first aid supplies on site in case of injury. And this includes having emergency numbers, the location address posted, and also a plan in place to what you're going to do if there's an incident. Are you going to call the ambulance? Are you going to transport somebody, and so forth? So when we talk about safety, we all talk about hierarchy of controls. And we're going to go back to this at the very end of the slide when we kind of do a little bit of practice. We're going to work our hazard muscles, focus muscles. So when we look at hierarchy controls, when we see a hazard, we really want to focus on the top three of this upside down pyramid because they're the most effective. It is eliminating that person's interaction with the hazard itself. So in the field, over the past number of years, the number of people involved in field operations have decreased. We're seeing harvesters that are going to not having crews on them. You're really only having harvesters and trucking and sometimes maybe some action alongside of the field. But the number of people has decreased, but there's still a number of hazards that are in the field. The biggest one is equipment, moving change, PTOs, pinch points, and the sheer size can be problematic of the equipment. Guarding is very important. If there are moving parts that someone can interact with, it needs to be guarded. During maintenance and cleaning activities, guards are removed and sometimes are not put back. So doing a pre-harvest inspection on equipment can help identify and fix these issues prior to going into the field. Daily inspections and walkarounds of equipment can also help identify damaged guarding, especially around those that are plastic-based, such as PTO guards or guards that are interacting with our storage equipment, such as our stingers and so forth. Having backup alarms on your equipment, trucks, tractors, even the harvester, helps those outside of the equipment be aware of backing up activities, especially around the harvesters. They do have a lot of blind spots. They are getting larger. Now, some of the harvesters will now have cameras on each corner to provide the operator some sight, but really the pedestrians really have that responsibility of being aware of their surroundings. Also, proper lighting, we really don't tend to think about it because we do most of our activities during the day, but proper lighting allows not only visibility of the equipment, but also allows the operator to see what's happening around them. People working in the field need to be aware of what they should and shouldn't be doing. This includes not walking between pieces of equipment or behind equipment, making sure that they get signals and so forth, and wearing proper PPE. So that's steel-toed boots. High visibility is a great way to kind of make people be visibly aware to operators in the field. And also signage at the start of the field can assist in kind of stopping people from entering the field when they shouldn't be there. Some things that can go wrong in the field, if there's not improper guarding or even working under equipment when it's not properly disengaged or shut off, you can have entanglement that can be around chains, even around the equipment itself, runovers, so running over feet or people with trucks, tractors. And then we tend to forget about eye injuries. Our fields can be dusty, so we can have blowing dust or debris. And if people are not aware of where they need to be standing, especially around the blower, there can be significant injuries as well. On the road, we have to move our equipment from one location to the other, and we cannot control those who are on the roads themselves. So a major one is left-hand turns. So it is the most common type of collision on public roads with agricultural equipment. Being aware of having signal lights and having your signal lights functioning is very important, and also looking behind you to see if there's any traffic oncoming. Visibility, so lights and reflectors, slow-moving vehicle emblems is very important. Check them pre-harvest and then do just daily checks. These will kind of give you visibility, especially around larger equipment. Make sure that your slow-moving vehicle emblems are actually present and can be seen with the implements. Defensive driving, so that just goes back down to awareness. Be aware of what's behind you, in front of you, beside you. People tend to think they can pass equipment safely. Sometimes that cannot happen. So if you're moving 2 or 3 pieces of equipment, just maybe ensure that you leave a space in between those pieces so that if cars do try to pass and it's a dangerous method, that they can kind of pop in and out as needed. If you can, change your travel times, go different routes that are less busy or during slower times during the day. And then power lines, we tend to forget about these. Usually if they're in good shape, there's no overload or there's no hot temperatures, they kind of stay where they need to be. But sometimes hot temperatures and a higher load will actually lower those lines, become a hazard, which can cause damage or actually fire or electrocution. So just be aware of where they are across the roads that you're traveling on, field access points, and also your headlands. And then finally at storage, it is a busy location. So just make sure you are inspecting the equipment. So look at your pilers, your conveyors, your air seps, your hogs, and all the other ones that you have there. And just make sure you're walking along the line and just checking that the guards are in place, or if there's guards that need to be added. So chains and sprockets are one, moving shafts is the other, rotating shafts is the other. the biggest instances I've seen around injuries in storages is the actual movement of equipment. So that would be with, you're moving your bin piler forward or back, or you're moving your conveyors and somebody's foot is in the way and gets run over, it's crushed. So being aware, sometimes you can put in a backup alarm on your machinery or on your conveyor or your equipment that kind of gives a little bit of a warning for people to step away. And then lighting is also important, especially in storages. People might be working outside and going inside, and if there's a differentiation between lighting, it is difficult. It also allows you to kind of see the trip and fall hazards that are present around loading activities. The other thing is heights. So we tend to forget that our potato boxes, or what we're delivering our potatoes in, are fairly high. And sometimes workers do need to access that. So just make sure you have a safe method of entry. Now that can be having a ladder with a work platform that's guarded at the back where the chute is, or a ladder that's attached to allow them to enter. A lot newer pieces of equipment actually have doors that allow you to enter the box rather than trying to climb over the side of it. The PPE, so same as in fields, you're looking at safety footwear, gloves, high visibility, especially in going from indoors and outdoors. It allows you to visually see people. You also want to wear work gloves, especially those who are racking or interacting with potatoes or doing any kind of work on the machinery. The other thing is noise levels. So rule of thumb is if you're standing next to somebody and you're at least, if you're standing next or up to an arm length away and you have to raise your voice to talk to them, then you're going to probably need hearing protection. And in storages, they are loud. Most of them are metal. Usually you might have some ventilation going. You have moving equipment, moving conveyors and pilers, so it can get noisy. And then the other part is also safety glasses, some sort of eye protection just to allow you with the dust levels. Housekeeping is also very important. I don't know how many incidences that I've heard of where people have stepped off something and stepped on a rock or a potato and twisted their ankle or sprained their ankle. So just making sure you're keeping your storage floors as clean as possible between trucks is very important. So what can go wrong in storages? Coarse entanglements, we all know of people fingers getting caught between the legs or between pieces of equipment, or clothing is another important thing. So just making sure that everybody's not wearing super loose clothing, that jewelry has been removed. You don't have any of the cords from the hoodies hanging down, or from coats that have kind of like a sash to it, that they've been removed or tied back. Hair is another one to be very aware of, to tie that back as well. Crushing, so the piler is moving side to side, making sure that nobody goes towards the end of the bin piler or at the front of the bin piler between the backing up equipment and so forth. Runovers, so you should ensure that people are backing up safely. So one of things that you can implement is just a pylon that allows the truck driver to kind of back up alongside of it, kind of puts them in a right place, and then you still would have the person who's backing up that equipment, but being aware that people should not be in that area or between the equipment when it's happening. And then slips and falls, transitioning from dirt to concrete can become slippery, especially if it's not ideal weather conditions. So just making sure you're cleaning off boots and keeping your floors clean is very important. So just going back, because we're running short on time, but hierarchy of controls. So elimination, very hard to do in storages and in agriculture, especially in the field and during harvest. Substitution, you can change equipment or processes to something less dangerous, but it does take time and money. The one that really is effective is engineering controls. So looking at your equipment and seeing what can happen if I interact with it, checking lighting, introducing work mats, rotation of positions, platforms in trailers, and even barriers that prevent equipment from interacting with an area where people congregate or walk. Administrative controls, those are policies, procedures, some signage and alarms. Those are all administrative. And then PPE, as I mentioned, is least effective. The person still is interacting with the hazard, but sometimes that is the only option or one of the options that is available. So I'm going to ask people to come into the chat. And we are going to look at these four. I've got a bunch of pictures. So we're going to look at the one that's on the furthest to the left. So that's the one that has the chain with the cover. So these are all bulk bodies. And I'm just going to ask somebody pop in and just kind of pop in what you see in these pictures. And then I'll go through these quickly and kind of let you know what kind of methods you can use to kind of properly guard it and protect your employees and yourself from injury. So I'm going to give it about 30 seconds. Okay, so the first one, which is on the left, is it's a chain and sprocket that drives the belt for the body. So here, right, Emily, moving parts with no guards. Pretty much all of them are moving parts with no guards. So this one, it is properly guarded on the front and the back, but the front and the top and the side, but the bottom isn't guarded. So in this situation, somebody could not be aware it's guarded and put their hand there and they're going to get caught. Ideally, it should be fully guarded underneath. Now you can do a full metal piece, or you can have a piece that has holes in it, but as long as you can't stick your finger in it, it's not that wide, then it should be fine. The second one is a power shaft. So this one drives the roller. And there is legislation around these type of pieces of equipment. So if the length of the shaft, including the collar up to the fixed points, up to the very top end of the point, is longer than half of the diameter of the actual shaft, which is that little, the bump out there, then it needs to be covered either by a guard or a non-rotating cover. Or in some situations, that bump out can actually be brought down to the same level as the collar, depending on if you need to grease it or not. The one with the white picture, that is unguarded. That is the motor driving the shaft to the roller. That needs a guard at the top and at the bottom and at the back. Right now, anybody could interact with it. Now, the bottom is a trick. This is actually properly guarded. So you have a pressure roller in the back that pushes the belt back into the truck. There have been a lot of instances, if this is not properly guarded, where somebody's cleaning underneath the chute and cleaning off the stinger, clothing can get caught, and arms unfortunately can go through that, usually ending with significant injury or amputations. Yes, perfect, couplers. So here again, exposed chain. So you kind of want to make sure that's done. The top picture here in red, you have an actual guard that's on this shaft, but it has no collar. And this chain is actually exposed. With this picture, I would probably wonder if it was a maintenance issue and the guard was not replaced properly or was missing. The bottom one with the yellow box, it is properly guarded, but does not have the right guarding fastener. So this is plastic, so it's easily accessible. What you want to make sure is that you use a bolt or nut. So somebody has to use a tool. It gives them enough time to think about the consequences of taking that guard off. Here you can just quickly remove it. And then the last picture is there's a bolt missing from it, so people can access that quickly. Some really good things, what it can look like. Well, you've got nuts in a picture, so do not operate without the guard in place. So it's giving people warnings. The top one, this is a piler, so there's a sign that says do not pass under the boom. You have this chain properly guarded. This chain is to pull it in and pull it out. So it's really not moving the chain itself all the time, but there is signage around pinch points, removing and so forth. This one is the drive shaft, where the motor is very well covered. There's no way somebody's fingers or hands can interact with that moving part. And then the bottom one is just a really good example of some pictures and warnings that you can give people around what's proper and what's not. So this one's telling you, there's a nip point, your fingers can get caught. And the last one is actually telling the people to shut off the equipment, which is really important. If you're doing maintenance on equipment, you're removing guards, make sure it's disconnected. If you can, lock it out. But if not, make sure that the plug is not plugged into the electrical. That way it won't start up accidentally. And I just want to say thank you to everyone for attending. And if you have any questions, as Emily, as they said, I can answer them at the presentation.
Thank you, Erica. That was great. Our next presenter is Todd Forbush. And like Erica said, we'll do questions at the end. So we're going to go through our next presenter and then we'll do questions if there are any. Todd Forbush is an engineer at Techmark Incorporated. He received his master's degree from Michigan State in agricultural engineering in 1989. While at MSU, Todd studied the effects of ventilation on the process quality of chip potatoes out of storage under the watchful eye of late Dr. Burt Cargill and Roger Brooke. Following graduation, he continued to apply his work to the commercial potato storage industry at Techmark Inc. The most enjoyable part about my job is working with the producers. They are the backbone of this industry, and I really like solving problems, says Todd. His faith in God, his wife Kristen, and his 3 children, Tyler, wife Jessica, and grandson Evan, granddaughter Madison, Taylor, husband Aaron, granddaughters Peyton and Sawyer, and Morgan, husband Hunter, granddaughter Mackenzie, and grandson Hudson, give him stability to address the tough questions that are posed each day in the potato industry. Todd is active at the Williamson Free Methodist Church and an avid outdoorsman. Todd, you are up.
Very good. Can everybody hear me? Hello, hello.
Yes.
Awesome. Thanks, Emily, for the introduction, and thanks everyone for coming along. Again, I want to echo the excitement we have of the partnership with Spud Smart. So thanks again, Spud Smart. Today we're going to talk a little bit about fine-tuning storage management and agronomy using potato sugars. So on we go. Again, questions at the end in the chat. We will cover those. So this time of the year, many of you, hopefully some that are on and others that will be listening, we've been having one-on-one conversations about how the pre-harvest sugar samples are helping reflect how this growing season impacted the crop's genetic expression through sugar sampling. So one of the things that we want to talk about when we look at sugar sampling is it's one of the keys to understand really what that crop is up to. As you're aware, the crop is producing glucose 6-carbon sugar through photosynthesis in the canopy. That's combined into sucrose, translocated through the stems and stolons out to the tubers themselves as we're building bulking yield and also maturing those tubers off. And then as we hit classical maturity, we'll see sugar concentration dropping and our specific gravity rising. And so those are the kinds of things that we're looking at. The way we work with tuber sucrose rating, we combine that with a canopy vigor. So it's important to look at how the canopy is doing relative to how the tubers are doing. So we work all of those things in together, and then we take a look at immature tubers or mature tubers based on what we see in those sugar concentrations. High nitrogen or low heat unit years are years where we might see maturity delayed. And again, nitrogen can impact maturity, and unused nitrogen pushes maturity or delays maturity. Issues compounded when other stress factors happen, they come into the equation. If we've got drought or disease, we see the sugar elevated because the potatoes themselves are using that sugar for the energy required to fight off those diseases or to deal with the drought. So the potato actually uses or carries free sugars around when it's under more stress, and it tends to pack those sugars away into starches for both yield and for gravity when there's not as much stress around. So our idea is to have a very healthy plant and to have that healthy plant producing sugars in photosynthesis and translocated down into the tubers for the best yield and gravity that we can get maturity is elevated, we want to check our maturity prior to any fall stresses. So for example, if we don't have any checks and we get a frost, we don't know if that sugar gets elevated because of the frost or if it was elevated because of an immaturity issue earlier in the season. So it's important that we get this pre-harvest sampling all done before we get to any kind of stress indications in the fall. Some of those can be heat related as well. So let's take a look at some of those numbers. So one of the things we do is we try and find out where that crop has had heat stress throughout the growing season. And we do that using the cumulative growing degree day calculation. Each day is given a unit of base 40 Fahrenheit. And we've also got the slide for our friends from Canada in C. So if you're working in degrees C, this would be the calculation for a base 5 degrees C. This is the calculation for a base 40 degree Fahrenheit heat unit. We take the maximum temperature and the minimum temperature, add them together and divide by 2. That gives us the average temperature for the day. And then we subtract the base. Again, in Fahrenheit, we're going to subtract 40. And in degrees C, we're going to subtract 5. That's going to get us a growing degree day for that individual day. Now, as you can see in this calculation, a growing degree day of 20.1 C, base 5, that would be a day that we would call stressful. So either our nighttime minimum is greater than 21 C, or our growing degree day for that day is over 20. That is a time where the potatoes are seeing more stress. Why is that a stressful day? Remember that photosynthesis takes place while the sun's shining and not when it isn't. But respiration takes place all the time. So all the living tissue on that plant, while it's using carbon dioxide to create the sugar through photosynthesis, that plant is also respiring. So it's using some of that sugar, giving off oxygen in a much lower amount than what the CO2 that's absorbed through photosynthesis, because the excess sugar that's produced that's not respired gets put down. So we've got more carbon being pulled in through carbon dioxide than the challenge we have given off through carbon dioxide through respiration. But at the same time, we've got a respiring tissue that doesn't have a source for its carbon. So in the nighttime, it's got to use the sugar it produced during the daytime. And respiration, plant respiration, is based on temperature. So when we have warm nights, we consume more of the carbon that we produced during our photosynthesis period, and warm nights lead to delayed yielding, bulking, and also can yield to lower solids. So as we see the warm nights come, or we see these high temperature days, we'll see solids impact and we'll see delayed maturity from days that are stressful. So we look from the time of planting on through either vine kill or harvest and take a feel for where our heat units are giving us stressful days. This time of the year, it's really important because if we've got a heat unit, a stressful heat day, we can cause sugars to set sugar ends or stem end color in chips, sugar ends and fries. And that's where we can run into some trouble with the defect that's difficult to condition out in storage. So once we're through with those heat units, we're going to talk a little bit about how to get those samples collected. So the heat units are something you can do kind of in retrospect. You can look back at that at any time. We use temperature information from public sources, and you can do this with any calculation. Take that heat unit and you can see where your crop was stressed out during the growing season. Pre-harvest sugar sampling collection, how should we do this? First and foremost, if you've got a highly variable field, where are you going to measure? Well, we're going to try and get the most representative place in the field. We're going to also want to know what our canopy rating and uniformity are. Canopy rating is just a 0 to 100 number that tells if it's a lush green canopy, that would be 100%, and a canopy that's got that's all dead, that would be 0%. So that's our rating. The uniformity is very important because it tells us if this expression of maturity is uniform throughout the entire field. If a crop is 50% uniform, that would mean that some of the field is dying and other parts of the field are green. Logically, if we take that field and go into storage with it, we're going to see a varying performance. Those tubers that are under the dead vines or dying vines are going to perform differently in storage than the tubers that are under the green vines. So the first thing we do when we're trying to sort fields using this information is we look for anything that's got a non-uniform canopy, and we try and make sure that that canopy rating, that crop is not put into long-term storage, because we know it's going to have variable performance coming out of storage. So what are some of the barriers to getting this information? And really, it's just a matter of being out in those fields. You can even incorporate your 10-foot dig strategies for yield estimations in with your collecting your samples to go into the labs for sugars. So you need to follow the SOPs when you're collecting these to make sure you get all the tubers from the individual hills in, so we can get a tuber set, we can get stem numbers, and we can get those individual vine health issues on the plants that we're bringing in. So those are kind of some of the things you need to pay attention to as we're taking those measurements pre-harvest out in the field. So once we've got that sample collected, we're trying to get at least 2 samples, one 3 weeks before and one 1 week before either vine killer harvest. And really, the closer to vine killer harvest that we can get, the better. We like to be within 5 days, but we will allow a sample within a week to say that that's a representative sample. What are some of the challenges if we don't get that sample close enough to the last time the vines are making deposits into those tubers? Well, let's say this week we're harvesting, we're digging green, we're north of the border, we're harvesting green potatoes, and it gets hot. Well, if it gets hot, and our pre-harvest sample was taken on Thursday this week, if it gets hot to the point where we're seeing stress based on our growing degree calculation we said earlier, then we know sugars are going to shift this weekend. And we're going to be harvesting a different crop on Monday or Tuesday than we harvested last week on Wednesday. Again, it's not like you're going to change these things. It's important to know where you're at. So what you'll do is you will measure those as close as you can to harvest, so you get a feel for what the last deposits were. Again, this is if you're doing green dig. On vine kill, when we're vine killing potatoes, we want to get that as close to that vine kill spray as we can, so we know what those last deposits that vine was making in those tubers. We want to know what that last deposit resulted in. We're going to go into that in a line, right in line on a row, and mark where we're at. We're going to take 40 tubers. So we're going to start digging in hill number 1. We get 8 tubers in hill number 1, 8 tubers in hill number 2, 8 in hill number 3. We're going to go on and dig hill number 4. We're at 32. We're going to dig hill number 5. We've got our 40 tubers. Now, we got to make sure then that we're going to count the stems on those. We're going to go ahead and get our canopy rating and canopy uniformity. That's going to tell us really what this crop is doing in that row. Now, we're not trying to represent necessarily the entire field. We're doing that by location selection. So we're going to select a uniform spot, and in an irrigated field, we're going to move at least in to the main part of the irrigation system or the pivot. We don't want to be taking samples out in the end gun or places where watering is going to be inconsistent. We want to get into that pivot far enough to know we got uniform watering taking place in that area. And again, 40 tubers are required. The labs will run the sugars. They'll give us sucrose, glucose, size, and specific gravity. And then that sample can be picked up, or you can drop it off, either way. So pre-harvest sample evaluations. This is the work that we're doing right now, is going through and trying to evaluate what these sugars mean to the end result. And we try and set these fields up. A green field is one that's in good shape, chemically mature, and ready to go into storage. Yellow field is one we may want to grow some, and if the vines are dead, it's one we're going to watch going into storage. And a red field, we're going to wonder, talk with the agronomy and the farm team about what happened in that field and figure out where the best place is to use that field to make sure it will maximize the opportunity that's in the field without really making troubles for any processors. We're going to try and look at these and group up similar fields with similar sugar profiles. We'll pair those together in storage. That'll allow us to tailor storage recommendations to those sugars. And any of the stress crops that we've noted, again, high sugar crops are high stress crops. If you look at a field that's been hailed, if you look at a field that's had drought stress, those types of things get reflected in the sugars very readily. You measure those, you look at them and try and figure out exactly where you're at, and then how to use those fields, again, to minimize the impact on the processing plant, but try and get what you can out of that field because you spent the time and money to grow it. Now we look at, we've gone through this, the pre-harvest, we've done our evaluations, we've grouped up our fields, and it's time for us to go into that potato storage. This is kind of the crossroads where we're going to hand off from the agronomy team to the storage management team. And I think it's really important to note here that in some situations, the agronomy team becomes disengaged at this point, and it's really not a good place to disengage your agronomy team. Even though they're busy doing things, preparing for the next growing season, it's important to keep them engaged because it's not the number of tons or hundredweight that you pull off of a field, it's the amount that goes through the processing plant in the top SKUs that really help us determine what our profit is. So if we bring in a lot of tonnage off of the field and we don't have good return on that going into the processing plant, we need to include agronomy in those decisions so we can help kind of fine tune some of those agronomy decisions and also define how the weather impacted the genetic expression. This year is a year where in a number of places, we've got decent maturity. Crops coming to maturity pretty good. We did see some stress, some heat stress in some areas. But again, the numbers tell us these things. We don't have to guess and talk about them. We use the numbers. So our sample procedure in storage, we take a sample every 2 weeks throughout the storage season. If we're in a spot where we're trying to monitor sugars closely, either trying to deal with potatoes that have been frozen in the field and we have to figure out what their recovery rate is, or potatoes that are nearing senescence, we're going to take sugars on those more often every week. But we need to get at least every 2 weeks going throughout the storage season to get that information in so we can actually follow and track those sugar curves. We're going to select a representative location in that bin. If we have multiple fields in the bin, we need to sample each field independently. We're going to flag those locations, and we're going to collect tubers from each of those locations. So in one field, we'll pick 2 locations, take 15 tubers from each location, 15 to 20 tubers from each location to come up with our total sample of 30 to 40 tubers. We need to have over 30, so we want to bring in enough to make sure that we're going to have that. We're going to take that top layer tubers off. We're going to take our sample container, and we're going to take, again, from 2 locations, we're going to take those tubers and put them in the container. We're going to mark those. The idea is, again, that we're not trying to get representation of the entire field or bin. We're trying to track how an individual part of the bin is moving. And then, again, if uniformity is good in the field, we can transfer that onto and uniformity is good with airflow, we can transfer that onto the entire bin. If you've got uniformity issues, we already marked that off in pre-harvest in the field. And if you've got uniformity issues with airflow, you talk with your ventilation contractor and get that taken care of. So, talking about storage management, when do we end preconditioning and begin cooling, or do we even use preconditioning? When do we actually start cooling this crop down? First and foremost, you got to make sure you got outside conditions to do that if you don't have refrigeration. This time of the year, it's really interesting working with potato operations that don't have refrigeration. It's warm out in a lot of growing regions. And so we've got to look at how we're going to manage through warm time when we've got freshly harvested tubers that are respiring at a high rate, kicking off a lot of CO2. That can cause challenges in the potatoes for sure, and we got to make sure we manage that properly. So first and foremost, we're going to try and make sure we cool potatoes down to 48 quickly in order to manage any rotting potatoes or pathogens. So if we've got any rotting potatoes, we need to try and get that temperature down. We just mentioned it's warm outside, so if you're going to have any challenges with bruised or rotting tubers, it's best not to harvest them because you're not going to get them to 48 degrees Fahrenheit, and the pathogens are going to win that battle. Our goal is to get rid of the pathogen challenge first, and then to deal with any sugar challenges second. So we're going to cool that crop down, make sure we take care of that pathogen challenge, if we've got the refrigeration to do so, we're going to get that crop cooled down. Obviously, we need to make sure that we're allowing suberization to take place. But again, active pathogens are your number one line of defense. If you don't have active pathogens, we're not going to cool that crop down. I think it's important to note that this says cool pathogen challenged rotting potatoes. Okay, that is a very good definition of potatoes that you can smell as easy as you can see them. Get them cooled down. From there, we take a look at that pre-harvest sugar information. If we had an immaturity issue or if it was in a yellow field, we're going to precondition a little bit longer. We're going to watch those sugars in the storage and make sure they're doing what we need them to, which is come in line, the quality's coming in, getting better before we take that temperature down. So that's going to help us determine when that preconditioning is going to end. We're going to use sugar samples to do that. If the crop is mature, then we may not even need preconditioning. We might just start a very slow curve or ramp down to 52 degrees. For most potatoes, they'll heal at 52 degrees as well as they will 55. I might just take them right down to 52 slowly. And if you're taking them down slowly, it'll take more than 20 days to get there. If you're over 20 days in storage, wound healing's done. So at that point, you can go on with your temperature cooling if outside conditions allow or if you have refrigeration. In there somewheres, you're going to stop for a few days, use CIPC if you're going to gas that building or other storage treatments if you're going to use those. You want to make sure that you apply those in a way that they're not going to stack stresses. So if those are stressful applications, different chemistries have different levels of stress. You don't want to have a cooling stress at the same time you have an application stress. Those stacked stresses are where you can cause more trouble in the storage. Field frost and immature tubers. Definitely if field frost has led to pathogen challenges, you're going to follow that pathogen line. If they haven't and they're just elevated sugars, we're going to run a longer preconditioning period to try and get those cleaned up. And we're going to use that crop in the early third of the market. Once we're in storage, sugar sampling, we're going to begin cooling when our sucrose rating is below 1 and our percent glucose is below 0.15. Now, the way that number comes out in chips, that's going to be like a 0.006 on our charts. In glucose, it's going to be below a 0.015 on our charts. So it's important that you get that number right. We'll work with you based on the sugar sampling protocol you're following. We'll tell you where that's at. If not, talk to the folks that you're dealing with at your sugar lab. They can help you out. We want to have acceptable process quality before we cool that crop down. Storage management and holding. If we're seeing proper holding temperature, we're going to see stable sucroses. We're going to see quality holding up in the high range, and we're not going to see a lot of off-color fries or chips. Stable to falling glucose and improvement, quality improvement as we're cooling. You can see the temperature we're cooling down. These are properly held temperatures. If we're holding too low, we'll see our sugars elevate. We'll see our quality deteriorate. The numbers of off-quality fries or chips will increase if we're holding at too low a temperature. So it's important for us to get that sugar monitoring going and keep it going because not every crop is going to store well at the same holding temperature. And that's going to be variety and market dependent. But again, if the crop is being held at too cold a temperature, you'll see sugars rise, you'll see quality deteriorate, and those are indications that you might want to change your holding temperature and warm it slightly. Again, that's going to depend on pre-harvest sugars and what your intended length of storage is. The storage effect on fry quality. So we're going to watch that ventilation system to get a feel for what's happening on that back side of the respiration equation. The labs monitor what's happening on the reactant side, so sugar and oxygen. The storage ventilation system is talking about what's happening on the product side, carbon dioxide and heat. So the reason we're ventilating potatoes is because they produce heat and carbon dioxide. They're respiring. If they're respiring at a higher rate, that means that they're under stress. If they're not respiring at a higher rate, they've become more dormant. So the potatoes are talking to us all the time. The question is, are we actually following that? So high respiration levels, that's high stress levels. and we need to make sure we're following those things. I always like to close these presentations down with a secret, or not a secret, I would say, just a statement that Dr. Cargill told me in 1985. He wanted me to make sure I understood before I left Michigan State University that these potatoes are complicated and they're never going to let us know all the secrets. So with that, I thank you for your time and again, open things up for questions for either myself or and I got to work my way back, Erica. Sorry, Erica, for not remembering your first name. Thanks, everybody.
All righty. Thank you, Todd. Okay, so now we're to our question portion. If there's any other questions, can you put them in the chat, and then we can answer them that way. We've got one from Bill Orr, probably either for Todd or Erica. What is the best way to deal with multiple languages on a farm at harvest?
I think you'll need to make sure that you have someone who speaks both languages and understands the safety aspect of things. That can be kind of a translator. I know with temporary workers, that can be an issue. And sometimes it's just demonstrating as well, and just making sure you're verifying that they understand what you're trying to show them or understand what the hazards are.
Makes sense. Thank you, Erica. This one's from Addie Waxman. Todd, when do you start sampling out of storage for sugars?
Thanks for the question. We start sampling as soon as we close the door. We want to try and get a feel for what the transition is from our field sugars to our storage sugars. There's also a period of time where sugar or potatoes go through what we'll call a storage hangover or harvest hangover. And we want to see how that sugar elevates, how the process quality slips during that first 14 to 20 days in storage prior to gassing for applications for sprout inhibitor. So that's kind of when we want to get started as soon as we close the door.
Thanks, Todd. There's a few more for you. Have you ever seen a sugar, this one's from Gabriel, have you ever seen a sugar level rise in storage because of too much ventilation to CFMs per 100 weight or more?
I've not seen the quantity of air movement change the sugar expression in storage, but the quality of air is really where that key is, Gabriel. So if your air quality slips, the quantity of air doesn't have as much of an impact on the air quality. And hopefully that answers your question.
Thanks, Todd. Another one from Scott Graham. When storing too cold, when does senescence sweetening occur? Does sucrose rise first or glucose?
Okay, so when we're talking about senescence sweetening and we're talking about cold storage, those are two different things. And I know Scott understands that. So cold storage, you're going to see glucose move first on cold storage. Generally speaking, you're going to see sucrose move first on senescence sweetening. And that senescence sweetening is that's varietally dependent. Okay, so it's important for us to have the history of the field and the storage performance and the sugars coming into that senescence period, which would be like our final third stretch of the storage. So May, June, July, or June, July, August, those time frames when we might see senescence occurring, that's when we count on what we've already got in terms of the crop performance. And we're going to watch both the way the air system is what demands are being placed on the air system, as well as the way the sugars are responding, to get both sides of that respiration equation in the mix to identify senescence sweetening versus cold storage.
Thanks, Todd. There's another question for Erica that she answered in the chat, so I'll just read it for everyone. It was, what advice do you have for smaller farms that may lack extensive safety programs or resources?
Yeah, so my reply was actually for the language part, but it actually goes back to the smaller farms as well. So, I mean, for smaller farms, you have local ag safety in Canada. You have the Canadian Agricultural Safety Association. They have wonderful tools in there. In the States, you have local areas of agricultural safety or AgriSafe. There's actually AgriSafe Week is 2 weeks from now, which they have some wonderful training around HTV, ATV, UTV, safety and so forth. And then also for smaller farms, take those 5 seconds and just kind of take a quick look around. Even just guarding pieces of equipment, making sure people can't interact, will make the site safety more safe. And sometimes it's just a very simple solution. And when you work with the machinery as much as most operators have, usually you can find a quick and easy way to kind of mitigate that hazard.
Thank you, Erica. Another question from Addie Waxman. Have you checked, this is for Todd, have you checked how weight loss and shrink are affected when you store based on sugar profile?
Right. So it's a great question. What we look at, and actually weight loss and shrink can impact sugar negatively. So if you have high weight loss, you actually are exhibiting a stress on the tissue and require extra respiration to alleviate that stress from within the tissue. So if you get into extreme conditions where you're having excessive weight loss, you can actually see sugars move up. So really, sugar profile is indicating healthy tuber. Healthy tuber is one that's not losing weight. So I think that, we always look at weight loss when we're managing. And what I mean by that is, high humidity, small temperature differentials, larger airflow rates. These are the things you're going to do when you're properly managing the storage. And they're really kind of right in line with sugar management. They aren't kind of opposed to each other, if that makes sense.
Thanks, Todd. There's a few more questions for you. Have you seen any sugar development based upon the sort of sprout suppression you've used? Does it have an influence on sugar development?
It can have, but it's mostly due to, if you start watching the entirety of the crop from pre-harvest through, you don't get surprises. If you've got a crop that's highly sensitive, you can get chemistries to impact the color and sugar development. You got to know if you've got a sensitive crop. You find that out before you get it into storage. If your crop is stable and healthy, very, very seldom do we see any issues with either CIPC, DMN, or better or worse one way or the other. If we're following the protocols for application, we've got some great applicators out there. The folks who deal with these chemistries, they do the job well. I can remember when I first started, there was a lot of discussion around chemistries and the impact on sugar accumulation. Well, stress, okay, but potatoes is stressed, it's going to increase the sugar because it has to. It's got to offset that stress through a higher respiration rate, which requires sugar. So we are doing a wonderful job, I think, in the application industry and the chemical development industry, trying to reduce the stress on the tubers. And in that case, we see far less impact on sugar development.
Okay, one last question from Addie. Have you ever experienced elevated sugar associated with potato sprouting in storage?
Okay, great question. Generally speaking, as potatoes are sprouting in storage, they're in a spot where they're respiring hard, which means they're consuming a lot of the 6-carbon sugar, and almost always sprouting potatoes fry. It's possible that your customer won't take them though. So I don't ever like sprouting potatoes. I don't think it's a good idea to operate a storage in a way that you do have sprouting potatoes. We all will see sprouts from time to time. We know that those have broken dormancy and they're in a different respiration phase. So generally speaking, higher CO2, potentially elevated sugars, but at the same time, elevated respiration is removing those sugars. So usually when they're sprouting, you don't see them go off color from high sugars because you haven't hit true senescence, you've just broken dormancy. So generally not, they generally improve during sprouting, but I don't ever want to get somebody sprouting tubers to try and improve their process quality. It's a bad call. So, yeah.
Alrighty, thank you. There's some more from, there's one more from Gabriel. At what level, CO2 level, will the sugars start increasing in storage?
And that's another one that's a bit of a challenge to put your finger on. You got to know how sensitive your crop is. Generally speaking, we try and keep CO2 levels below 3,000, but I've seen beautiful frying crops with 6,000 parts per million in them. It really depends on how sensitive that crop is and how that CO2 elevated, if it was a quick elevation due to heavy respiration, or if it was a prolonged elevation over long periods of time.
Alrighty. Thanks, Todd. Thanks, Erica, both of you for your presentations. Just a few upcoming events I want to go through real quick before we pop off. We'll have a newsletter. NAPSO will do their newsletter in October. We'll send that out to our mailing list. If you want to get on our mailing list, go to our website and you can get the email there. Spud Smart will also be doing an edition. Their next publication will feature the webinar and some takeaways from today. We'll also have another webinar in November based upon the AIM Act. So if you don't know what the AIM Act is, you should. If you want to know more information, you can attend our webinar. There's more details to come on that, but we'll be pretty vocal and there'll be a lot of lead up to that webinar. It'll be a really good webinar to attend. And then this webinar will be posted on Spud Smart and then our NAPSO YouTube if you want to refer back to it or send it out to other people. That's all I have. Dawn? Oh, you're muted.
Of course I was. I kept saying, don't do that. This was really fun. It was a great really great presentations. I learned a lot. Hope everyone else did. And thanks for being part of our first joint webinar. I'm looking forward to doing more.
Thank you.
Have a great day, everyone.
Have a great day. Bye.
Have a safe day. Bye.
Bye.